Hi everyone, this is lesson 1-1, video 1.1.2. I did not include that on here, so I will write that on here, video 1.1.2. And our learning target for today will be for students to learn about describing subsets of real numbers in set builder and interval notation. Specifically, in this video, we will focus on interval notation. In example 2, we will be using interval notation to describe an interval or inequality of numbers. Now in example 1, we have to write the inequality -2 is less than or equal to x is less than or equal to 12 using interval notation. Now interval notation is basically the same thing as set builder notation. However, you're using kind of a shortened notation here to describe this inequality. So here's the deal. In interval notation, it almost looks like an ordered pair. When I'm talking about ordered pair, you learned in pre-algebra or algebra how to plot points like 1, 3 or 0, 0 is the origin. Our notation in interval form is going to look similar to plotting a point or giving an ordered pair, except for sometimes we're going to use parentheses and other times we're going to use brackets. So our interval could look like this with parenthesis, comma, parenthesis, or it could be parenthesis, comma, bracket. It could be bracket, comma, parenthesis, or it could be bracket, comma, bracket. These are the four different notations we could use for interval, writing an interval for an inequality. So here's the deal. We are going to write this in interval notation. If the inequality sign is less than or equal to or greater than or equal to, you are going to use brackets because that means the value is included in your inequality. So for here, we're going to use a double bracket because we have less than or equal to and greater than or equal to. So this is greater than equal to here and less than or equal to here. And so what we're going to do to write our interval notation is we're going to use a bracket, -2, comma, 12, bracket. And again, the reason why I'm using the bracket is because we are including 2 and 12 in our interval. So if I look at this and say -2 is less than or equal to x, which is less than or equal to 12, if I substituted -2 for x, -2 is part of my solution because -2 is greater than or equal to -2. Now similarly, I could also put a positive 12 in for x, and 12 would be less than or equal to 12. So the reason for using the brackets here is because -2 and positive 12 are both included in the interval provided by this inequality. You may also think about this inequality in terms of its graph. The graph of this inequality, if we graph an inequality on a number line, we know that we have -2 here, then -1, then 0, and then a whole bunch of lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 would be right here. And if we are going to graph this inequality, because -2 is included and 12 is included, we would put closed dots on -2 and 12 to indicate those are solutions to our inequality. And then we would shade everything in between those values because we only want the values that are greater than -2 but less than or equal to 12. Okay, for example B, we're going to use interval notation again, except for this time we're going to graph the inequality x is greater than -4. So I'm going to start this time with the graph of that inequality. And if I look at 0 being the middle of my number line, I would have -1, -2, -3, -4 here, and then 1, 2, 3, and 4 on the other side. And if I'm going to graph this inequality, here we have x is greater than -4. So I am going to put an open hole on, or an open dot on -4, because -4 itself is not greater than -4. So since -4 does not satisfy this inequality, I do not include -4 in my solution set, and I do that by providing this open hole on -4. Now, if I am going to shade the numbers greater than -4, all the numbers greater than -4 are to the right of -4, so I'm going to shade the entire number line to the right. Okay. Now, because I don't have a double inequality here, I only have a single inequality, meaning I have a starting point for my inequality. I have a starting point where I start shading, and I shade infinitely to the right. There's no stopping point like I had in the last example where I stopped shading at 12. So what I need to do here is I start my shading at -4, but -4 is not included in my interval, so I'm going to use a parenthesis around -4. Okay, I'm going to start my interval with a parenthesis because -4 is not included in this inequality. It's not a solution to the inequality, comma, and then I need to figure out the next number, which is where I end. Well, since I never end my shading, I'm going to shade infinitely to the right, and if the largest number possible, if something is increasing or going on forever without stopping, that means we're going to shade infinitely towards in the positive direction. So then I'm going to have positive infinity as my ending point. And since infinity really isn't a number, but it's a concept that something is continuing in a direction without stopping, then I would use a parenthesis. Because infinity, there's no stopping point, so I can't include infinity because infinity is not an actual number. There's no distinct stopping point. I would always use a parenthesis for infinity. And this is our solution to this problem. Our interval is parenthesis -4, comma, infinity, parenthesis. In example 2, part C, we're going to use interval notation again, but with two separate inequalities. We want to write x is less than 3 or x is greater than or equal to 54. Now, I'm going to start by drawing a number line, and I'm not going to number all the way up to 54. I'm just going to kind of sketch or estimate where 54 and 3 would be on the number line. 3 might be here, and 54, let's just say, is way down here. Okay, there's a whole lot of numbers in between 3 and 54. But I'm not going to label out 54 tick marks on my diagram. Okay, so here's the deal. I want to shade x is less than 3. So first of all, I need to decide, do I include 3 in this inequality or not? Is 3 less than 3? And I would say, no, 3 is not less than 3, which means that I am going to not include 3, which means on the diagram I'm going to have an open hole on 3. And now I want to shade all the numbers that are less than 3, which means I'm going to shade the entire number line to the left of 3. All the numbers that are less than 3 are to the left of 3. Now, similarly, with the next inequality, I'm going to graph x is greater than or equal to 54. And in this case, is 54 greater than or equal to 54? I would say yes, 54 is greater than or equal to 54, which means I'm going to put a closed dot on 54 and then shade everything greater than 54, which means I would shade the entire line to the right. Okay, so I'm thinking about this. The shading that I do on this number line is not connected in any way, like it has been. It isn't continuous like our previous two examples. So when I write this inequality in interval notation, I actually have to write two separate inequalities. I have to write one for this shading here and one for this shading over here, because the two pieces of shading on the graph are not connected. So I'm going to start as far to the left as possible. Well, if I'm going to shade infinitely to the left, this number over here is negative infinity, meaning I'm shading in the negative direction as far as I possibly can go, which is towards negative infinity. So I'm going to start my first interval at negative infinity, comma, and then I'm going to stop that shading at 3, but 3 is not included, so I'm going to have a parenthesis there. Now, because I have two separate shading areas, I'm going to connect these two intervals by a union. Okay, if you think about a union being two people getting married, they talk about marriage being a union between two people. You're combining two people into one lifestyle or one marriage, and so, or one family. So here we're going to connect our two interval notations with a union. That's what this symbol means, U for union. And the other shading can be described by the interval. Since we're going to include 54, I use a bracket, and I'm going to shade from 54 all the way to the right infinitely, so my ending point for this interval is infinity. And remember, infinity is not a number. It's just a concept that something is moving in a direction without stopping. And so I can't actually include infinity, so I always use a parenthesis around infinity. So this would be our interval for this inequality here. So in example 2, I want to check your understanding here. I want you to write the interval for x is greater than 5 or x is less than -1 using interval notation. You have 4 choices here, A, B, C, and D. And I would like you to choose the correct answer, or the answer that you think fits this inequality, and then press submit.